Alright, excuse my voice, I have a cold. This is my setup for generating electricity as a demonstration. What I have here is a smart drive brushless motor from a washing machine. It's a front load washing machine. It has a ring of magnets around the outside that spin around these copper coils. And the washing machine was designed so that the electricity came in from your wall socket and energized these coils. 1, 2, 3, 1, 2, 3, 1, 2, 3. They're in series. There's 42 coils around this. And as the electricity came in, it would push against these magnets and cause the tub of the washing machine to spin. So the electric companies generate electricity. When it gets to your house, it comes in here, goes through these coils, and they hit the magnet, and your induction makes it spin one way or another, or agitate back and forth, what have you. I'm reversing this. Instead of the coils energizing themselves from the electric company and making the magnets spin, pushing and pulling on the magnets, I'm going to spin the magnets around the coils and force them to cause or to make electric current. If you watched my video, well, any of it, the static charge of the ether is gravity as it feeds atoms, but a magnet automatically accelerates gravity. If you watched my explanation of how magnetism works, these magnets inside this ring are little plates from here to here, if you can see. They're just enough to cover 3 coils at one time, but the magnets alternate south, north, south. Then the next plate will be north, south, north. Then the next one south, north, south. So they alternate. So there's always a south and north, south and north going by each coil. South and north, south and north, south, north, south, north. So it alternates back and forth between south and north of what direction the magnetic field is going past each coil. And the coils are in threes. 1, 2, 3 to 3 wires. 1, 2, 3 to 3 wires. And for every third coil, it's like you have a green, a black, and a white wire. So it'll be green, black, white, green, black, white, green, black, white, green, black, white, all the way around all 42. So you have so many that are green, so many that are black, so many that are white. And as the copper or the magnets pass by, each black one will get a north, each white one will get a south, and each green one will get a north. Then as the rotor turns 1 notch, it reverses. Each black one will get the opposite, each green one will get the opposite, each white one. So it alternates back and forth. As my video showed, the north side of the magnets push the charge as the magnet passes by, it causes it to force the charge, the static charge, accelerated gravity, through the coil and out the wire. Now the next one, the south one, is doing the opposite. It's pulling the charge into the coil from the wire. So it's back and forth, and each one goes back and forth. Push, pull, push, pull, push, pull. And they alternate which one's doing it at what time. But each of the 3 on each wire, 1, 2, 3, and black, red, green, or black, green, white, black, green, white, black, green, white. So all white ones are pushing at the same time, and all black ones are pulling at the same time. And as this magnet goes by, each color is pulling or pushing all together at the same time, but each color is doing something different, if you understand that it's timed to alternate at a particular way. So that's what the electric companies are doing at the generating stations, using coal or atomic fission or whatever to create heat to make steam to turn a turbine. So my setup here is this is the rotor with the magnets inside this ring, which turns outside these stationary stators on these brackets. The brackets are mounted to the base and they stay stationary. The shaft goes through a hole in the stator plate here that holds the copper coil stationary, and the shaft is in a pillow bearing here, goes through that. It's welded to the outer ring of copper magnets, and it goes to this other pillow bearing to a handle. This is actually a pulley, but I've just made a handle. So if you'll notice, as I turn the handle, the magnets pass by the copper coils, one after the other, one after the other, north, south, north, south, north, south. Just keeps alternating. and it doesn't matter which direction you turn this, you get the same result. North, south, north, south. So as it comes out of each coil, it goes in through my wires here to the bridge rectifier. You got black, green, and white. So that means that the push-pull, push-pull, push-pull out of these three, when it goes to the rectifier, only the pushes can go out the black one, and only the pulls can come in the white one. So it basically means any coil that's pushing going out goes out here, and any coil that's pulling pulls back in and goes back in here. So it's back and forth. But once it does this in these two wires, it transforms it from AC to DC, one direction, out and back in. It's like a gate. It's a one-way street now. Instead of back and forth, this can only go out the black wire and in the white wire. So it turns it into a DC system. And if you notice, I've got a receptacle plugged up to my output, DC, out the black, in the white, and two switches. The switch on the right runs these bulbs on the right, which are in series. In other words, the DC goes in this bulb, through the filament, out to this bulb, through the filament, out to this bulb, through the filament, and then back in the white wire to a coil that's pulling. Then when another coil is pushing on this other side, these are in parallel, which means that each bulb's getting a push into it at the same time, and when the push comes out the back side, it goes back out the white wire. So I hope some of you might know the difference between in series and parallel. In series, the charge has to go through all bulbs before it gets to the system, and in parallel, it goes through each bulb at the same time to come back to the system. So it's all about time. It takes longer for this charge to make it through all the filaments, as opposed to the quick time, it goes to each filament at the same time on this side. So that's the difference between in series and in parallel. But this is running DC now because of the converter. The parallel puts a higher load on it because they're all three getting the same amount of accelerated gravity, electric current, at the same time. As to where the series, it has to go through one to get to the next, to get to the next. So it has a longer distance to go. It's all about time. It's all about the amount of time it takes for the accelerated gravity to feed the atoms it needs to feed. So my point being on this, I've taken a simple brushless smart motor from a front load washing machine, and I'm reversing the way it works. Instead of the electricity coming in, energizing the coils and pushing or pulling against the magnets to turn the tub of the washer, I'm turning the tub of the washer to make the magnets energize the coils, push, pull, like I showed in my other video of how a magnet, the accelerated gravity on a magnet. If you watch my magnetic demonstration, you'll understand how the other part works, where I showed how the north and south pushing and pulling works. And this is to show how if you do that fast enough with enough coils pushing and pulling, you get an electric current rather than just a little charge on a meter. So I'm going to turn on, well, I'll leave it off, and I want you to listen to how when the magnets pass by the steel cores inside the copper coils, there's a steel core inside each one, as it passes by, it grabs a little, and you'll hear a whining sound. Okay, that's with no load on it. There's no charge being distributed to the bulbs or going anywhere. So the faster I spin that, since the accelerated gravity has nowhere to really go, it just makes a bigger magnetic field around the stators and the magnets, creating the acceleration of gravity in these coils. The magnetic field just gets bigger. It has nowhere to go. There's no need for it. But once I turn on some bulbs, I'll put the ones in series on, you'll notice the sound gets a little louder, growly, and the bulbs are kind of lightening up. And the faster I go, the higher the whine, and the brighter the bulbs. And the ringing you hear is just my handle. I've got a slip. That's the ting you hear, but the grinding is the magnets. So that's the bulbs in series. That's about as fast as I can spin it. So now I want to show what the bulbs in parallel do. Since these are all three getting it at the same time, and these bulbs are even, 25 watt, both on the end, These are 25 watt. I blew my other clear one over here, but I've got another 25 watt. And these are 40 watt on the ends. So it's 25 on both sides, 25 on both, and 40 on both. So now I've turned on the parallel side. Now listen to the grind. Much louder, but look at the brightness. And it's much harder to turn. And it's all about time. How long does it take for this charge to get to each bulb? Right now it's quick. It's going to all three at the same time, so it takes more energy to energize them all at the same time. When I put them in series, it's a slower time. It has to go through each bulb to get to the next one, so it takes longer for the juice to do that, so it doesn't take as much juice and they don't burn as bright. So I wanted to make that clear too. But that's what it is. Accelerating gravity, which a magnet automatically does, the way a natural magnet does. When you pass it by a copper coil, the acceleration from the magnet itself, the magnetic field, causes the copper to also accelerate. It's the direction of south or north acceleration, outward or inward, that gives you your alternating current. Tesla figured this out years ago. And I figured out much more than this, but this is the next step of my experiments and demonstrations to show you how it works. I just wanted to take a quick moment here to show you, as the picture's showing, if you can see the size of a generating station that's at our power plants, where they use burning coal or nuclear fission with radioactive materials to create steam, which turns a turbine, which turns a rotor like I'm showing with my little washing machine motor here. But these things are huge. The size of the magnetic fields that the magnets, or they use electromagnets a lot of times, they pass that by, or pass the rotors, the coils inside there pass electromagnetic fields, but they spin them with turbine pressure from steam. I mean, they're huge. Just wanted to show you the difference in size of the capacity of the power that they generate to power our grid. This is an AC induction motor. It's out of a chainsaw. The chainsaw broke down, the parts of it, so I kept the motor. This is meant to plug directly into the wall, but I can plug it into my generating station here and run DC into this motor, and it will turn. But I'm only using half the motor's capabilities, because this is meant to hook into the wall, which is AC, means it works on the north push or the south pull. And if you understood what I said before, how the orientation of the magnets tells the coil whether it's pushing the gravity, accelerated gravity, out the wire, or whether it's pulling it in from the wire. This will work both ways. When one's pushing into the motor, this coil causes it to turn the motor that way, it pushes it over. But when another one's pulling out of the motor, that coil pulls it. So they push-pull and makes the motor go in one direction. But I wanted to show you how I can run half of this, just the push side, off of my DC rectifier here in my system. Turn the bulbs off, and I'm plugged right into my DC receptacle, and you'll see I can get a little rotation out of this motor. And I get pretty good RPM. But it'll run an AC motor on DC, and I'll explain some of that later. But what I wanted to explain to you is that the power companies are just making accelerated gravity. They send it to us, our washing machines, our electric chainsaws, our TVs, everything else just takes that accelerated gravity and it uses resistance to slow it back down to normal gravity going into the earth. To that speed, that normal gravitational speed that holds your feet to the ground. That's the natural speed of the gravity where we're at on planet Earth. So I wanted to explain that. Thanks for watching. I wanted to make one more point about this AC generating thing I've got here, is that back in the day, before Tesla came up with AC, they would generate electricities with something like this with fewer coils, but all the magnets were north, basically north out. So it always pushed, just like a battery or any DC. If it's the north magnet only pointing towards the coils as it goes by, it's always pushing. pushing the charge away, pushing the charge away. And it was DC. And then Tesla came along and figured out how to go north-south, north-south to make it alternate. So you could also use just south. If all these magnets were just south, it would constantly pull it in, pull it in. So it would be like a reverse, backwards system. Instead of it being north and pushing, it would be all south and pulling in. But I wanted to just throw that in there, that back in the day, they did use north, or didn't use alternating till Tesla came up with putting at least 4 coils on a system like this, 4 big coils, and going north-south around them with magnets. That's how he just devised the alternating current. Like I said, if you went all north, if all the magnets were north, it would push out. If all the magnets were south, it would pull in. This just reiterates my theory and my explanation of how a magnet works. It accelerates gravity, which gravity is the static charge of the ether that supplies the strong force to all atoms of mass. It just depends on the density of mass and the type of number of protons in each atom, which determines the atomic number on a periodic scale. But a magnet automatically accelerates gravity. It doubles it because it's got twice the distance to go through to supply the same number of atoms as it would if it was just normally gravitational. And that pushes it to why the north of a magnet pushes and the south of a magnet pulls, is because of that acceleration going through it one way with the north diverted to south input, as my theory shows it. Just wanted to explain that about north and south, how it makes all north could make a direct current out and all south can make a direct current in, but when you go north-south, 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 it alternates, and it's better for the big transmission lines to alternate because it's not trying to push it all one direction or pull it all in one direction. It's just shooting it back and forth real quick, which gives it more flexibility to get it farther distances with less energy and less problems.